Okay, now coming to another kind of question, like when people talking about the current flowing through the metal and the amount of we know if you take small amount of material, we know we are talking about moles, which is of 10 raised to 23 atoms. But how many electrons are actually contributing to the current? So suppose I am interested in a simple case, the laboratory kind of case. A 10 milliampere current is flowing through the wire of thickness 1 millimeter. Okay, 1 millimeter thickness I have taken for easy calculation, but it is also close to 22 gauge wire, which is 0.7 millimeter, and 18 gauge wire, which many times 22, 18 gauge wires we use in the laboratory. If you're talking, I'm talking about single stranded wire. Okay, and then 18 gauge wire has 1.2 millimeter thickness. So I'm taking somewhere order of magnitude. How many electrons are moving per unit time per square angstrom? I'm saying square angstrom. Why? Because typical size of atom is an angstrom. So when you consider one particular atom, how many electrons are effectively flowing? That we want to calculate. Sometimes these numbers can be calculated just out of fun. I mean, you may not really make big application, but this gives you some good idea of the order of magnitude that is happening at this level. So 10 milliampere current is same as 10 millicoulomb charge flowing per second, and 10 millicoulomb charge is 10 into 10 raised to minus 3 coulomb divided by charge on 1 electron. So basically it is 6.25 into 10 raised to 16 electrons flowing. Okay, but that is those are the total number of electrons flowing through the entire thick wire. Now, through 1 millimeter thickness, we have typically pi r square. If you consider 1 millimeter thickness is actually diameter. So if I take pi r square, then this is the 0.78 square millimeter. And when I convert that into angstrom, 1 millimeter is 10 raised to 7 angstroms. I get a number like 7.8 into 10 raised to 13 square angstrom. So that 1 millimeter thickness wire, if I consider the area of cross section in terms of square angstrom is this, and then 6.25 into 10 raised to 16 electrons moving per second per this much area. So per square angstrom, it is going to be about 800 electrons. Okay, so you see that about, you consider one particular atom, okay, about 800 electrons per second are flowing across that. Okay, this is one. I mean, this gives some interesting idea to students, at least at order of magnitude level, that how many electrons are flowing. To give some basic idea, this of course later can be taken for statistical analysis and those kind of things. But this inquiry into the numbers becomes very useful skill